Good morning, my name is Stefano Miccoli, and today I will present the research project called Teaching Structural Design to Architecture Students, Experiences at the Academy of Architecture in Mendrisio, Switzerland. Until 2014, the teaching of structural design, and particularly of the courses of reinforced concrete, timber and steel structures at our university, followed a traditional approach consisting of theoretical lessons about physical and mechanical properties of the materials, structural analysis and design of common structural elements, practical exercises based on academic examples, and final written exam, where the students were asked to solve a simple structure like the one shown in the slide. Analyzing the participation of the students at the classes, the results of the exams, and the evaluations and comments given to the courses by the students, we had to admit that we needed to change something. First, we have searched for some references in the field of the improvement of the relation between architects and engineers, and in the field of alternative approaches to the teaching of structural design. Then, we prepared two questionnaires for student and professional architects to investigate the relationship between architects and structural engineers, and to identify which structural engineering topics are considered useful and important by the architects. The results of the first part are listed in this slide. The relationship with structural engineers is considered good, is generally good, the contribution of structural engineers to the architecture projects is well valued, structures are considered an essential part of architecture. There is a desire of a better understanding of structures, but also a lack of education in the field. And there is a recognition that better and earlier collaboration would lead to better projects. The results of the second part were more difficult to analyze. There are many I don't know answers, which indicate a difficulty in understanding the questions. Then the range of votes is often not concentrated around average, indicating that there isn't a shared opinion about many of the topics, many of the questions. But we can conclude that there is an interest to have some tools to be able to set up a good structural layout and to communicate constructively with the engineers without being involved in calculation. It is also interesting to analyze the answers to some of the open questions. For example, one of the questions asked to name some structural engineers that, in your opinion, have given an important contribution in the field of architecture. The names that were mentioned more are Pierluigi Nervi, Eduardo Torroja, Riccardo Morandi, Santiago Calatrava, Robert Maillard, etc. All engineers that were devoted to the field of conceptual design. We set up three didactic experiments based on the results of the questionnaires, but also on some considerations about the way of learning that are more familiar to the students. The students spent most of their time in the design laboratories, so they are more familiar to practical works. The research of references is considered very important, and they are used to work in groups. So, the first experiment consisted of the analysis of an existing building and the construction of a scale model to show the structure of the building, and it was applied to the courses of timber and steel structures. The second experiment consisted of the conception and preliminary design of a new structure, and it involved the course of steel structures. Here the students were required firstly to develop an architectural idea, which is the starting point of the structural choices, and then to develop a structure that could respond both to the architectural and to the static needs. The third experiment consisted of the analysis of an existing building freely chosen by the students, but coherent with a specific topic. The main focus of the analysis was to understand how the structure can create the architectural space by itself. And the exam consisted of the realization of a model of the structure and the photograph of the model, highlighting the relation between the light and the architectural space created by the structure. As shown in this slide, the experiments had extremely positive outcomes in terms of exam results, of number of failed exams, and in terms of interest by the students. And also the comments by the students became very positive. For example, they wrote, "I really appreciated the exam method. The constant revision with the teaching assistant allowed us to understand very well the structure that we analyzed. I really liked the idea of working on a project that I could choose." In conclusion, we can say that the questionnaires administered to students and professional architects highlighted some difficulty in understanding the analytical language used by the engineers, but at the same time showed great awareness of the importance of structures in architecture. The experiments carried out tried to solve this problem of communication, adapting the programs and the didactic strategies to the interests and needs of the architects. We think that the meeting point between architects and engineers can be the conceptual design of structures, and that the teaching should favor the growth of the awareness of the importance of a fruitful collaboration with the structural engineers. We also had an unexpected result. The possibility for the student to freely choose the building to analyze has given us, professors and the teaching assistant, a different point of view on our profession. We didn't know many of the projects chosen by the students, and through their choices we have better understood their interests and their visions about the role of the structures. We definitely gained a new perspective about our profession, experiencing the advantage of a good collaboration also for the engineers. This is the end of my presentation. Thank you very much for your attention, and I'm available for any question.